We're going to talk about section 1.4 in your book, Fitting Linear Functions to Data. So I picked a few points here, 3, 1, 4, 3, 6, 6, 8, 12, and I just plotted them by hand. You can see them there on the screen, and the blue dots represent the data points. And what we're interested in, when you look at that data, you can say, well, it sort of looks like it falls along a straight line. And so what we are trying to determine is, how do we find the best line to approximate the data that we're giving? And so that's called a line of best fit. Now, you did some of this in your Algebra 1 days, but that was a long time ago. And if you decide to take AP Stats in your future, you'll do this in much greater detail. But we are going to use our, now when you're thinking about a line of best fit, it's not totally obvious what would be the best criteria to use. And that's a discussion that I'm not going to get into. But some things you might think is, should we try to draw the line so that it hits as many points as we can? Would it be better to maybe draw the line so that there are the same number of missed points above the line as there are below? Or is there some other criteria? And you'll talk about that in great detail if you do AP Stats. We're just going to talk about here how to use our calculator to get that. And the technique that we're doing, what we're actually going to be using, is what's known as linear regression. But we're going to let the calculator do the hard work. And you're going to just have to know how to use your calculator. So I'm going to try to walk you through that as best I can here, given that I can't pull up my calculator screen here. So if you need to pause it at any point along the way, so that you can get caught up with your entries into your calculator, feel free to do that. So we're going to start by hitting the stat button on your calculator. So you're going to have to find that. It's on the third row, third button over. And then once you have done that, you want to hit, it's already on edit, so you're going to just hit the enter button. And when you do that, you should see like L1, L2, L3 up at the top. There may be some data in there already. If there is, we want to clear it out. So to clear the data out, you're going to hit your up arrow until you get all the way up to where your cursor is on the L1, the actual L1. So that's called the menu bar. And then you can hit, once it's on there, if you hit clear, the clear button, and then hit enter, it'll wipe everything out in that whole row. And so that will start you with a clean slate. Then you can just enter all of the X values into L1. So you just want to put those in there. 3, enter 4, enter 6, enter 8. And you want to put the Y values into L2. And same way. And so if you need to pause at any time to get caught up, that's fine. So I've already got mine entered in there. So what we're going to do next is to actually calculate that line of best fit, what's known as a least squares line. That's what that's called. We're going to find the least squares line. So to do that, we're going to go back to the stat button. So we'll hit stat again. And then after you've done that, you're going to right arrow so that you move the cursor onto the calculate menu. And then there's actually 2 different ways you can do linear regression. It doesn't make any difference which one you do, but option 4 is going to be Lin Reg Linear Regression, and that's what we want. So once you get to there, then you can just hit enter. And depending on how old your calculator is, if you have an older model, then I may have to show you how to do this differently, but my calculator now shows X list and it says L1, which is what I want. Y list says L2, which is what I want. Frequency list is blank, and that's what I want. I'm going to down arrow until I get to the store reg equation. So we're going to store the regression equation into this. So what I want to do there is I'm going to put y1. So I'm going to go to the variables button, VARS, VARS, stands for variables. That's the 1, 2, 3, 4th line. It's right to the left of the clear button. So when I hit that, then I'm going to right arrow onto the Y variables. So that you should see that on your screen. And function will already be highlighted. So then I'm just going to hit enter. And then you should see Y1, Y2 all the way down. We want Y1, and that's already highlighted, so you can then just hit enter. And that will just copy that Y1 symbol into that line where it says store regression equation. So what's going to happen after we do this in a moment, the calculator will automatically copy all the decimal places of accuracy on our equation into the graphing menu for Y1. So I'm going to down arrow now to calculate, and then I'm going to hit enter, and the calculator will then compute the linear regression. And so I'm seeing that it says y equals ax plus b, and it's telling us that a is 2.13, and it goes on and on and on, and it's saying that b is negative 5.7, on and on and on. So that is the equation of our line of best fit, where the a is the slope and the b is the y-intercept. Now, if you hit the y equals button on your calculator, you will see that the calculator has already copied this down with all the decimal places of accuracy into Y1, which is nice. That's what we want. That's a huge time saver. So we're going to now graph this thing using our calculator. So it's going to get a better graph than what I could do there. Pencil and paper by hand that you see earlier on this. So we're going to turn our stat plot on. So we are going to go second. So to turn the stat plot on, we're going to go hit the second button and then hit the y equals button. And when you do that, you should see stat plots. Now, if you hit enter, then that's going to put you right into that first stat plot. Then you want to hit enter again to turn that on. Now, it should have defaulted, but unless somebody has changed yours or done something different with it before, the type should be that very first one should be highlighted. If not, go down arrow and then hit enter on that. The X list should say L1, and if it isn't, then just go down there and type in L1. You can do that by going second 1. And the Y list should be L2, and similarly, if it isn't, you can down arrow, right arrow, and go second 2 button. I like to mark that kind of square button on the very end. That's going to be what the data points are plotted, and I just think it's a little bit easier than if you have a plus sign or just a dot. Then what I'm going to do is actually tell the calculator to graph that, but I can tell it to pick the best window to fit everything in. So I'm going to hit the zoom button, which is the very top row right in the middle, and then hidden out of sight is zoom 10, which is zoom fit. And if you hit that, the calculator will choose an X-min, Y-min, and so on that will put all of the data in there, so you'll be able to see it all. So I'm there, and I'm gonna hit enter, and then you'll see a graph, and you'll see a bunch of little kind of rectangles, squares. Those are your data points. I'm gonna try to sort of show you what you're gonna see. You should be looking at something like this, and then it will automatically graph that line of best fit, which is in Y1, and mine looks like it's going to kind of hit that second one, but kind of go in between the others. So you can see something like that. Okay, now I'm going to do more with this in a minute, but I'm going to get a screen, and I want to talk a little bit about what's known as the R value. So there's an R value that determines how good your line of best fit is. This is a measure of how well your line fits the data. And we'll do this in a moment. I'll show you how to do it on your calculator. But the R is always a number that's in between -1 and +1. So an R value that is close to either 1 or -1 means that line is very good. Means the line is a good fit. An R value close to 0 is a bad fit. So that means, as I'm going to try to give you some examples here, that either it isn't really a straight line, it's something else, or the particular line that we have, our line isn't very good. So let me just give you some examples here. So here's a made-up data set. So if our data kind of looked like that, that sort of does follow pretty well a straight line. It's not perfect, but it looks like a straight line, and it looks like it's going to have positive slope. So this would have an R value close to +1, maybe something like 0.9 or something like that. So the positive because it has positive slope, and close to 1 because it's a pretty good fit. If our data looked maybe something like this, not too bad for a straight line also, but now this is falling from left to right, so whatever line would approximate that would have negative slope. That's going to be an R value close to -1. If you had some data like the one I'm going to show you here, where it looks like, like this one is not a straight line, that maybe looks like a parabola or something, that is going to have an R value close to 0, because a straight line isn't going to fit that data very well. Or I should say maybe that data doesn't fit a straight line. Now, if you have like random points there that don't look like they really fit any curve at all, that can also give you an R close to 0. Okay? So what we're going to do then is now use our calculator to find the R value for our data set. So we're going to find R. So we are going to first go back to stat. So we're going to hit that stat button, and then we're going to right arrow to the tests menu. So we want to go to the tests. And so I'm going to do that. And then you can see a whole bunch of different tests there are there. We want the linear regression t-test. So you're going to look for something like that. And let's see where that is. So it's actually all the way down at F. So once you get to F, then you can hit enter. And when you do that, again, you're going to see X list is L1, Y list is L2, some things we don't really know. And where it says the regression equation, that's what that REGEQ is, we want to put in Y1 there again. So remember, you're going to go to variables, hit that vars button, and you're going to right arrow to the Y variables, and then hit enter for function, and then once you get to Y1, hit enter again. So that'll copy the R1 there. Then again, drop down to the calculate line there, calculate. And once that's highlighted, then just hit enter. And it'll give you back a whole bunch of stuff. So if you down arrow, eventually you're going to see S, R squared. One more line is R, and the R for our data set is going to be 0.987. So that's really close to 1, which is saying then that that's really a good line of fit. So that's a good approximator right there. Now we're going to use this now regression line, and we're going to use our regression line to approximate some more data. To approximate two different values. So first, let's approximate f of 5. Now 5, if you remember our ordered pairs in the beginning, the x values went from the smallest one was 3 to the largest one was 8. And since 5 is in between there, since that 5 is in between 3 and 8, then what we're doing here is called interpolation. And in AP Stats, Mr. Hogshead would say this is an okay thing to do. We're going to do the next one we're going to find after this is going to be f of 10. And since 10 is outside of the data of the x values, this is called extrapolation, and that is in general frowned upon by stats people because you're assuming that our data is going to continue to, those same conditions are going to continue to hold outside of where we actually have sample points, and that's kind of a dangerous assumption. So anyway, what we're going to do is we have our, to approximate f of 5, we're going to again use our calculator. So we're going to go back to that y1 and plug in 5. So remember, you're going to hit the variables button, right arrow, enter, enter again, and y1 will show up on the screen. The left parentheses you will find right above the 8 button, and then you can type, so once you've got the y1, you hit that left parentheses above the 8, then you just type in your 5, and then the right arrow is above the 9, and when you hit enter, the calculator will actually plug 5 into that linear regression line, that our line of best fit that we did, and calculate that using as many decimal places of accuracy as your calculator can hold. And then you can repeat that process with the 10. And let's see, I'm going to go variables, right arrow, enter, enter, parentheses, 10, enter, and I'm getting 15.644. Very good. All right. You can hopefully now give homework number 7 a try.